Hey, it's Mr. C again, and I got little David here, and we are going to make a little short video on how to solve some quadratic equations with irrational solutions using completing the square. So I'm going to start out kind of different though. This is probably not something you've seen before or seen yet. We do it a lot in Algebra 2 and pre-calculus, but I'm going to let's suppose we have a quadratic equation with two solutions. X equals 3 plus the square root of 2, and x equals 3 minus the square root of 2. So if I look at those two solutions, I'm going to build a function, or I build an equation based upon those two solutions. So I'm going to move everything over to the left-hand side and set each of these equal to 0. So if I move the 3 over here and the root 2 over, I'm going to get x minus 3 minus the square root of 2 equals 0. Over here for this one, if I move the 3 over and the negative root 2 over, I'm going to get x minus 3 plus the square root of 2 equals 0. Now this is kind of interesting because these are both now going to be my factors that I'm going to multiply together. They're going to give me a quadratic equation. So here I have x minus 3 minus the square root of 2, and then times x minus 3 plus the square root of 2 equals 0. Now that's interesting because if I look at the structure of these two guys right here, it kind of starts to look like a difference of squares. So if I put parentheses around this, I'm going to try real hard here to not get my marker on everything. I have something here and then something here, the same thing, and I have a plus and a minus. Well, that has the structure of a difference of squares. So what that really is x minus 3 squared minus parentheses the square root of 2 squared equals 0. All right, if I expand this x minus 3 squared out, I'm going to get x squared minus 6x plus 9. And then the square root of 2 squared is actually just 2. So minus 2 equals 0. And so if I now combine these two constants, I'm going to get x squared minus 6x plus 7 is equal to 0. So the cool thing here that I've done is I've actually made an equation and I already know what the two answers are going to be. And this is something you can do at home. You can do it anytime, and you could just practice the skill by yourself without even having a teacher there or anything. So now I'm going to hand this off. Don't erase it because I'm going to write that equation up here. So I need x squared minus 6x plus 7 equals 0. All right, so I'm going to use completing the square to get this into what we would actually call vertex form, and then I'm going to solve it using square roots. So I'm going to take negative 6 divided by 2 squared equals negative 3 squared, which equals 9. Okay, that's the number that's going to help me. And I didn't do something up here, did I? I went ahead and just started dividing. What I was supposed to do is move that 7 over. So I'm going to go ahead and do that. X squared minus 6x. And remember, I was supposed to move the 7 over. So equals negative 7. All right, that 9 now is that value that goes in here, and it also has to be added to the other side. So plus 9, plus 9. All right, so here we go. This is now a perfect square, and that is going to be, if you remember, x minus 3 comes down here behind the x squared. Okay, and that's going to be equal to negative 7 plus 9 is 2. All right, if I now use square roots to solve this, if I take the square root of both sides, the x minus 3 comes out, equals plus or minus, and I'm going to have the square root of 2. Now, if I go ahead and move the negative 3 over in front of the plus minus, I have x equals positive 3 plus or minus, plus or minus, yep, plus or minus square root of 2. So I see that I'm going to get the two answers I started with. And so this is something that works very well. And they're both irrational solutions, so you really can't do anything with this. If somebody wants a numerical solution, you'll have to turn the square root of 2 into a decimal and then add, subtract and add to 3, and then you'll get your two decimal solutions if that's something that somebody wants you to do. Otherwise, you just leave it like this right here, and then you're fine. All right, so now let's go ahead and do another one. And this time, I'm gonna pick a slightly more complicated pair of solutions. X equals 2 plus the square root of, or 2 times square root of 3, and x equals 2 minus 2 times the square root of 3. So slightly more difficult, but then we're gonna see what to do sometimes when you have to simplify a square root. So again, I'm gonna take everything, move it over to the left-hand side, and get both of these guys equal to 0. So here we go, x minus 2 minus 2 root 3 equals 0. And I know that looks really complicated, and I know that people are gonna start to get kind of uneasy about that, but don't worry, it's gonna work out just fine here in a few minutes. This one is x minus 2 plus 2 root 3, all right, equals 0. Now I'm gonna take these two guys and I'm gonna multiply them together. X minus 2 minus 2 root 3 times x minus 2 plus 2 root 3 equals 0. And that looks complicated too, and it would be, unless we've got our friend the difference of squares happening again. That's a little trick that we can use to make our lives a whole lot easier. So it's really gonna be x minus 2 squared minus 2 root 3 squared. And that's gonna look like this. X minus 2 squared minus 2 root 3 squared equals 0. And notice how I use parentheses here. I always use parentheses because otherwise I would probably make a mistake if I didn't, especially with that square right there. So expanding the first term right here, I'm gonna have x squared minus 4x plus 4 minus, and 2 squared is 4, root 3 squared is 3, 4 times 3 is 12. So cleaning up the constants here now, I have x squared minus 4x, and that would be minus 8 is equal to 0. So that is my new quadratic that I want to go ahead and use completing the square to see if I can get these two solutions back. All right, so I'm going to need that for just a minute, David. So don't erase that bottom part. Okay, so we got x squared minus 4x minus 8 equals 0. All right, so now I'm going to actually do what I'm supposed to do next and move the negative 8 over. So x squared minus 4x is equal to, and that would be positive 8, right? Okay, so now I'm gonna do my completing the square trick. Negative 4 divided by 2 squared equals negative 2 squared equals 4. That's the number that goes here and on the other side to balance it out. So now I'm gonna have a plus 4 here and a plus 4 there. So again, why do I have to add it to both sides? Because you always have to keep that equation balanced. Otherwise, if it's unbalanced, then you're gonna get a different solution and it's a different equation. So now, the left-hand side is a perfect square, x minus 2 squared equals, and 8 plus 4 is 12. And that is a good sign. I'm glad that equals 12 because that's what's gonna give me my 2 root 3 here in a minute. I'm gonna take the square root of both sides. The x minus 2 pops out, equals plus or minus the square root of 12. Now that square root of 12, some people might leave it like that. I don't like to, because you never know when you can simplify an expression with a square root like that. So I always like to simplify my square roots. So if you take the square root of 12, and I'm gonna do this on the side here, and you make a factor tree, that's gonna be 4 times 3. 3 is prime, so I circle it. 4 is 2 times 2. Okay, and if you remember, a pair of factors here is worth 1 on the outside of the square root. So these two 2's are going to come out as a 1 single 2 on the outside. The 3 is going to stay inside. And there's our 2 root 3 right there. So x minus 2 equals plus or minus. And we'll just substitute root 12 for 2 root 3. Okay, now we're going to bring that negative 2 over in front of the plus minus. And x equals positive 2 plus or minus 2 root 3. And those were exactly the 2 solutions that we started with. And so we know we got it right because we got at the end what we started with at the very beginning. So this is a great little video if you need some help in solving some quadratic equations with irrational solutions. And we hope to see you guys soon.
Wait.
All right.
Wait.